compound inequalities. We've already talked about um, inequalities and solving multi-step inequalities. These are what we call compound. And if you remember, um, up to this point, we've only been working with one type of inequality. Now, a compound inequality are actually two inequalities. Or it could be more that are joined by the word and, or. And so what we're going to look at are these two types of inequalities. One where we would join the inequalities with the word or, and what happens, and the other where we would join two inequalities with the word and. Now, or inequalities have a tendency to graph apart. So the two graphs will be going separate ways. For example, as we look at these two inequalities that are joined by the word or, well, if I graph numbers or x less than or equal to -2, so we'd have a closed circle on a -2, less than would be shaded left then. And then if we were going to graph numbers or x greater than 3, open circle on 3 and everything shaded right. So notice that these two graphs, they're graphed apart. They don't share anything in common. One's going one way and the other's going another way. Now for our interval notation, we would need to show this in interval notation for the two graphs. So this one, this graph, it's a closed circle on a -2, and then we're flowing or we're graphing left, so comma, and then we'd have a negative infinity, and then the parenthesis. Now the other graph, we put the word or between them because these two inequalities are joined by the word or. The other one, open circle on 3, and then it would flow to the right, so infinity, and then parenthesis. So let's just take a look at one more example of an or graph. Let's take a look at, let's look at number 1, I guess. So we're going to solve each of these for x. So on the left-sided one, they're subtracting 4, we'd add 4. So x is less than 3. And then we would have, or excuse me, a -3, because a -7 plus 4 is a -3. Or, and on the right one, the right inequality, we would divide both sides by 2 because they're multiplying by 2. So x is greater than or equal to 6. So we have these two inequalities. We're going to graph both of them. So we have an open circle on -3, everything shaded left. And then we'd have we'd have a closed circle on 6, and everything shaded right. So notice again, it's an or, so the two graphs are separate. They don't have anything in common. Now for the interval notation, then we would have open circle on a -3 and flowing towards negative infinity, or, and then bracket, because it's a closed circle on 6, and everything shaded towards the positive infinity. And basically that's what or compound inequalities are doing. One thing I do want to mention is that when we write this part of it, make sure we write the inequality that is flowing left or graphed left first, and then have the inequality where it's being graphed to the right. Usually that's the format that we would use. Now let's go to and. Now, and inequalities have a tendency to graph together. So they're going to share something in common. An example on this, if I were to graph numbers greater than or equal to a -6, closed circle on -6, everything flows right. And for 1, a closed circle on 1, everything flows left. So notice we have an overlapping area, and this is what is meant. So notice this area right in here. Any numbers in that area are going to make both of these true. And remember, in an and statement, any solution has to make both of them true. Now the interval notation is a little different since we have the closed circle on -6, and then we have the closed circle on 1, so we have brackets, and the -6 is on the left, so we have this on the left, and the 1's on the right, so we have that on the right. Rewriting and inequalities. All right, because the solutions to an and inequality fall between the two endpoints, they are frequently written in a more condensed form. So for example, if I have the x is greater than or equal to -6 and x is less than or equal to 1, there's a little bit more of a simple way or condensed way we can write this. And we put the letter right in the middle, and we're going to write these two inequalities. Now, we're actually going to take this inequality and we're going to flip the x and the -6 around, which means that we got to flip the sign. All right, so then we just write it like that. So if I read this from right to left, it would be x is greater than or equal to -6, and then I put the other inequality, which is less than or equal to 1. So notice that we have the 1 inequality, which was this one, and then we have the other inequality, which was this one, and that's in a more condensed form. Now let's go over an example of this. Let's look at number 6 up here. So I'm going to take the 1 inequality, which is, and I'm going to write it over here. We have 2 is less than or equal to x plus 4, and I'm going to solve that. So they're adding 4, subtract 4. So we have a -2 is less than or equal to x. Or in other words, x is greater than or equal to -2. And then we're going to take the other one, this inequality, and solve it. So x plus 4 is less than 9. They're adding 4, subtract 4, so x is less than 5. Okay? So now we would write this in that condensed form. And I'm kind of flowing into these other problems, but that's okay. We're just looking at the number 6. So we're going to put x right in the middle. We have x is greater than or equal to a -2. Notice I read it from right to left. And then I have this one, which is x is less than 5. So all I'm going to do now to graph this is, well, here's the far left number, here's the far right number. So I have a -2, closed circle, because it's less than or equal. And then I have the open circle on 5, and then we just simply shade everything in between. So anything in the shaded region, including the closed circle, would make both these inequalities true. And the interval notation would be bracket -2, and then 5, and then closed circle. So anyway, that's just a kind of a quick summary of what compound inequalities are, and they are joined by the words and or.